first thing here, you were putting things into categorical versus quantitative. Okay, so categorical and so on. Any questions on these first A, B, C, D? I did have a question about E. The grade levels. I mean, I could see where you could think you could average those, but I think saying an average grade level of 1.5 would be kind of weird or something. I think if it was the age of people in elementary school or something, I don't know. So I think I could see it being bins of first, second, third, fourth, and then you'd like put the people in those bins. It'd be more kind of in categories. Yes.
Is categorical separate from qualitative?
No, those are the same thing. So categorical and qualitative, because that's a quality. Categorical and qualitative are the same thing. Quantitative is a quantity. Okay. Now, number 2 actually has an important concept that I want to make sure I stress with you. Okay, so, I could just go, it's D, but it kind of brings about an important point that I want to make sure I hone in with you, because I don't think I've stressed this unit quite enough. Okay, in which situation would the mean be the appropriate measure for central tendency? Basically, when would you want to use the mean to describe the center? That's what that's asking. And so, first of all, it has to be quantitative because you need to be able to get an average. Okay, so that's first, which that in itself marks off B because that's categorical, and that marks off this one here because those are bins and those are categorical as well. Okay, so that's that. Now let's talk about A. A brings me to the point of when you want to use mean and standard deviation versus when you need to use median and IQR. And that answer, which you might want to write on the top of your review, is this. If you have skew or if you have outliers, don't use the mean and standard deviation because they are affected by outliers and skew. Okay? We know that for a fact because we've seen if the mean is pulled in the direction of the skew and such. Okay? And we know an outlier can pull the mean very much so in one direction. Okay. So that's your rule. If you have skew and outliers, mean and standard deviation is out of the question. Don't use mean and standard deviation. Instead, you want to use median and IQR because you would basically to get the median and IQR, you're knocking off those edges. So you're knocking off a lot of the skew and our outliers. Okay? So you use this instead. All right, questions on that? So then that brings us to A. Most of the scores are near the minimum, a few are in the middle, and there's almost none near the maximum, but we do have a couple. So we've got something going on where most of them are here in the minimum, a few in the middle, and then, but hardly any out here. So this is describing a situation of skew. So if this is describing a situation of skew, then the mean and the standard deviation are not appropriate. So the mean's not an appropriate center. So that's why you don't want to use A either. Okay. Does that make sense now? All right. Now, with 3, you see here, I just put these fractions. I didn't even put the percents because, to me, I wanted you to see the work of how I got those numbers. So it's all about what's the denominator. Everything was the denominator on the first one. 498, so out of the Tarrant County ones, out of the Tarrant, and then out of the neosurgery ones, so out of these 76, okay? And then, last part, so now we're going to figure out, are these independent? And if they're independent, we got to do the marginal, and we need to do the conditional. So here we go. Marginal by type of operation. So the marginal is coming from the margin, or the total column, okay? So that's how I knew it was 60 out of 1489 and so on. So these numbers, okay, over the total. All right. Now, at the top of the next page, it asks you to do conditional. So don't you remember that If you go this direction for your marginal, then your conditional are these two subgroups here. There's a subgroup and there's a subgroup. That's your conditional ones related to this marginal. So see, you're always going to be going in that same direction. Don't mix them up and then go side to side. If you could go side to side if they all go side to side. Okay, that would be called marginal by county. See, then you'd have like 498 over that, so you'd have the total of the county. Okay, and then you could do each one with the county. All right. So at the top here, I know it was a lot of data, and I want to talk to you also about the rounding issue and how you draw your conclusion. Okay, so let's talk about that. I went ahead and pulled these marginals. I probably should not have rounded to the whole number. I recommend rounding to the tenth place, and then compare. And here's the deal. With some fractions, you literally cannot get the same number. Okay? It's impossible, to use whole numbers and get, if I did 20 over 498, that won't be, and I couldn't do 21 over 498. I can't get the decimal the exact same as this, just because of the nature of the denominators being different and how that works and plays into decimals. Okay. So by going to the tenths, you can see if they're like within a point. That means that it's this fractional issue causing why they're a little off. Okay? So in this case, these were really close. That thoracic one was 4.02 and this one's 4.03. So they're not perfect, but they're a little off. And they're a little off because the nature of the common denominator, or the denominators, they can't be the same unless you find a common denominator for them. Well, but then I guess that's kind of doing that too with percent. But okay, same idea. Same idea, because going to 100 has to be divided differently. All right, so therefore, these ended up being the same. So if they're within a point, then that's this common denominator thing, or this denominator. You don't have to put this sentence here that I have. I used to do that, and that's not required. What I say of you guys is two sentences, one about it being independent. So the conditionals matched the marginal. If the conditionals do not, if the fact that you are Tarrant or Dallas does not change the rate, then that is independent. Good. Independent, independent, independent. When the fact that you are one thing, so like the fact that you are Tarrant or Dallas does not change the rate, okay? So that's not going to change it. Therefore, you are independent. And then make a numerical statement. Well, they were all the same, and I didn't want to list all those, so I just said all of the conditional values. So I'm making a statement about their values for each county match the marginal perfectly. Okay. Questions there. All right. Then here, number 4 is another box plot, of which that's one of your free responses. There were no outliers on this one, so you ended up just putting in your whiskers to the min and max. Okay. Now, let's talk about this one. First, make sure that you label what you're doing, because if you don't label this, then the numbers mean nothing, okay? This class is all about what do the numbers mean, and, life is all about context, and so you have to have context. Life is context. If you don't tell me what that is, then these numbers mean nothing. All right, so make sure you did that. And then what's over here on the left is the counts. Well, that's the frequency, okay? So that's your counts. How many are in each one of those bins? Well, I kind of have two different situations here, and somebody told me this one's supposed to be 3 and this one's 0 here, but if you did your bins by 5, then those would have looked like that. I actually thought it looked better doing them by 10s, because look at how nice and symmetrical. I mean, look at that. That's beautiful. Unimodal, almost symmetric, right there. Okay? So either way, the same. They didn't define for you the bends, so either one of those is adequate. All right. Questions on that? Was there just something else up there? I had this here because it was in tens, yeah. And then I just put it on top of it when I grouped them in tens. Okay. All right. Then this is a dot plot. Okay. Questions about doing your dot plots. I actually had somebody ask me how to construct those, and I don't think I really probably went over that too much. But you know, like for instance, you're taking your 43 and you're going to put that as a dot in the bin it goes into, and so on. And of course, you don't have all those squares normally. I mean, you need to have. I gave you a grid like that so that you could make things have equal space, so all the dots could have equal space. Okay, and then you just stack them up. There's another 43. Put it in that one. Okay, and so on. Again, label, 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 label. And then I think it asked about the shape. Did it? Okay. It's kind of skewed left. You don't have to put this line on here. That I think I did that just to kind of demonstrate how it's skewed left. Okay. All right. Now I have something very important to talk to you about on number 6. Something I noticed this morning I actually have incorrect on my key. So we gotta make sure we do this. I have it set it, and I want to make sure that you catch on to it. It says oh no, that's 31. Wait. Okay. Okay. So first, make your key, and don't forget about that. I made the key from this section right here, where 30, is 30 minutes for Clinic A, and then 31 is the clinic minutes for Clinic B. You see how my key has context in it? Okay. All right. So you need your key. Then you have all your stuff there, and so hopefully you did all of those. Let's first answer the question here. Which one would you pick? If you wanted to do the best record as far as waiting time, which one would you pick?
B.
Oh, B for sure. It's pretty much better. And well, technically A did have a couple of them that were shorter than that one. But otherwise, what kind of things can you say about distribution B as opposed to distribution A? It's less varied. Uniform it's almost uniform actually, because uniform would be like all of the things are the same. They're almost that way. So almost you could say that. Less varied because they are less spread out. They only encompass, actually I think the range is from the lowest to the highest, like 20, 21. Okay. So good, less varied. I think that's a very good reason. And of course, they're more closely clustered to the lower numbers.
But I said data closer to minimum. Is that incorrect?
Oh no, that'd be good. Okay. There's lots of ways you can do support on that. You pick one and you support it. All right. I kind of think this one, if you picked A, I'd have a hard time you supporting it, because I think B is pretty clearly the better choice. Now, here's the new thing. Okay, that you need to watch out for. Here it is. So, when we talk about the shape, and we talk about first, let's, stand here and then tilt our head sideways and look at this here. Okay, so let's look at that distribution. And this is like our number line. Then we can say, it's fairly symmetric. It's kind of hard. It's unimodal, of course. It's almost hard to call it symmetry because you just kind of have two lines there, and then that one there. That one's almost up there. So I don't know. But look here. If I turn my head and now face this direction and I go like this, what am I going to say for my shape over there? Okay. It appears skewed left, but it is not skewed left, okay? And the reason it is not skewed left is because your number line is going the wrong way. Skewed left would have like the 0, 1, 2, 3, would be if you went this way in your number line. So when you turn your head to the side on this one, your number line is going the opposite way. So therefore, what is this thing, what can you really have to think of it like? Flopping it up, like reflecting it. Reflecting it so that it's looking like this, and you've got your 0, 1, 2, 3, 4, and so on in the correct direction. So then it actually is what? Skewed right. Okay? Just a little tidbit to watch out for. In fact, see, look here, I boo-booed when I made my description. I had said originally when I did my key the first time, skewed left, and it's actually skewed right. Okay? This one has you compare. We actually are going to spend a whole lesson next week about comparative language. So there won't be a compare your socks on this test. There might be a socks, but not compare your socks. So again, so with the outliers, not really one in Clinic B, but there appears to be one in Clinic A at 108. See, be specific, at 108. Okay, for the center, what center is appropriate for this? Based on that thing I told you a minute ago. Median. Why is median appropriate? Because I have two things. I got skew and a possible outlier right here. Okay, so median would be a better center to represent the data. Now, why not what? Okay, I could do mode. True. Yeah, I could do mode. It's between mean and median, which are generally the ones that we want to use if we have the ability, like the individual pieces of data. Okay, then median would be the one. Okay, and so I did that. And if you use median on one, use the median on the other. Don't compare the median on one and the mean on the other. Okay, and then spread. Clinic A is more spread out. Clinic B is more clustered closely, or has smaller range, more clustered closely together, something along those lines. Okay, so lots of different language you could use there. We'll go into specifics later. Yes, did you have a question? Okay, all right, any things on that? So the moral to this story is watch the direction your number line goes. In fact, I have seen our textbook, and I have to watch this. Our textbook sometimes has these as like 9, 8, 7, 6, 5. Watch that. Okay? Alright, next. Okay, here we go with the links of the geckos, the lizards. We got 10.1 for the geckos, 2.2 for the anoles. Anybody know how to pronounce that? Anoles? I don't know. Okay, I actually tried to look it up, but I couldn't find a pronunciation. I didn't look very hard. Okay, so standard deviation of 1.1 means that the lizards are what? Closer together around the mean. So guess what they are? More homogeneous, more the same. Okay? So standard deviation, a smaller standard deviation has things more the same than a more spread out data. Okay? So that's B. I think 8's pretty straightforward. D. Now let's look at 9. Okay, so here's another back-to-back stem plot. Okay, so this is 49 schools on the left in that 89 to 90 school year, and the same 49 schools on the right in the 92 to 93 school year. Okay, the deal is this. Actually, you could probably go through B, C, D, and E and do some computing that they have. But look here at A. The dropout rate decreased in each of those 49 high schools between, from 89-90 to the 92-93. Okay, so can I tell that each one of the 49 high schools did decrease their rate? So, like, if this was, say, James William Taft High School, do I know that it went from here to here and went down? I don't know. A stem plot does not give me a mapping from this high school, to this to on the left to the same high school on the right. I do not have that mapping. So, is it possible that some of the high schools could have gone up? Absolutely. This one could have gone up to this one. And so that could have gone from 20 up to 30. Right? So, because I don't have that mapping from those 2 years, I can't say that they went down. They all went down. All right. Any other questions on that one? Okay, means greater than the median, skewed right. Next. Okay. So number 11. Number 11 did not say the rule to do the outliers. If it doesn't say the rule by which to compute the outliers, then you have a choice. Okay? I happened to use the mean plus 2 standard deviations rule. Okay? And actually, you know what? There's one on the test that I have to fix because last year we found that with one way it makes an outlier and with another way with the IQR rule it doesn't, or something, so it was inconsistent. So I've got to fix it so that the answer comes out the same regardless of whichever method you use. So, you have to watch that. All right. So if our upper fence is at 163.82, then this maximum, we know we have one piece of data that's above that. So we know we have at least one, because it could be more than one. We don't have all the individual pieces of data. Okay, and then for minimum, the fence is at 94.2, and the minimum is right here at 96. That's inside the fence, so no outliers down here. Okay, so here's the deal. If you have an upper outlier, you know you have at least one, because you could have some of these ones in the middle here. We do not have a lower outlier. If we did, we could say at least 2, because we'd have at least one down on the bottom and at least one on the top. So then that's the case you would know at least 2. At least 2. I don't know how you would know this. No more than 2. E and C, the no more than 1 and the no more than 2, I think you would have to have all the pieces of data given to you to be able to tell that. And we don't. We just have the maximum. Okay. All right. Now, 12 is all about the percentages. I think that we've forgotten the percent of data that's in these quartiles. So here on A, where it says, okay, the IQR is 8. We're good on that. B, 75% of the students scored at least an 82. Well, look, at 82. Above the 82 is 1, 2, 3 quartiles. So that is 75% of the data. So that's why that's true. But when C says nearly half of the students scored below an 82, that's this 25% below an 82, and that's not nearly half. So that's the false one. D is correct. 1 out of every 4 students got an A. And I know that because here's the A mark. So this section here is my A's, and that's 25%. So about 1 every 4. And so on. Everyone passed the exam except for one student, and that would be this one that you can see right here. Okay? Not to talk about anything for tomorrow. Okay. Hey, I think 13 is kind of a neat problem. Okay, you ready? Given that the population has a standard deviation of 0, man, how can you have a standard deviation of 0? That means that, what does that mean if the standard deviation of all the numbers is 0?
They're all the same.
They are all the same, because the distances from everything to the mean is all 0. Good. So all the numbers are the same. Okay, good. So if all the numbers are the same, then is the standard deviation of a sample going to all be 0 also? Yeah, say all the numbers are 32, 32, 32, 32, 32, 32, 32. I'll pull a sample of them. I'm going to pull a sample, and what are all the samples going to be? No, all the pieces of data are going to be 32. So they will also have a standard deviation of 0. Okay, 2 says the sample mean. of a sample drawn out of the population is 0. Is the mean going to be 0? No, not necessarily. I just told you it could be like 32, 32, 32, 32, 32. So it's not, the mean is not necessarily 0. It can be whatever. They're just all the same. All right, and the last one. The sample mean and the median are equal for that sample drawn on the population. Why are they equal? Because they're all the same. That's right. Very good. So they are equal. So 1 and 3 are the answers there. Okay. And 14, tell about the smallest standard deviation. Okay, so here's kind of the best way I can justify this. How about if I get rid of all this mess of stuff and then try to re-explain it? Okay. All right, so standard deviation. Distance away from the mean. Okay, all right. I'm trying to figure out how I figured out the mean. I mean, why did I just like, how did I put those numbers in there? Did I just like take its place? I don't know. You know, this line. Maybe I guesstimated the mean. Because they look kind of like they cancel each other out, so this would be the mean. Okay, so for whatever reason, I guesstimated that as the mean. So let's talk about the distances away from the mean. How far are all of these ones here away from the mean? Well, these are only how far away from the mean? Like 1 or, okay. So these are at most 2 away from the mean. Okay? So all of my data is only 2 away from the mean. In fact, I only have 4 values that are farther away than 2. That's the key. So then when I come over here, probably the mean's going to be in here somewhere because, see, it's like symmetrical, you know, and so they kind of average out. So let's see. 5's the mean. So here is the ones that are 2 away from the mean. How many are farther than 2 away? 1, 2, 3, 4, 5, 6 are farther away. So more items are farther away. Got it? That's the deal. So let's do this one. Where's the mean going to be on this thing? Oh, see, we got 3 sets of 3s. So the 1s and the 9s, the 8s and the 2s, the 3s and the 7s, the 6s. Okay, so we're going to have the 5s also on this as the mean. Okay. So here are the ones within 2. How many are more than 2 away? 6 and 6. 12 numbers are more than 2 away. All right, let's go over here. Here's that. Let's see how many. Okay, here we go. 7, 8. Okay, so that's like 15. So I had 15 numbers farther away, and this was how many? Something. Okay, 12, and then 6. So this was only 4. So this one has the smallest standard deviation, and then D has the largest. Is there more numbers farther away? Okay, so you see that kind of idea there? By the way, if you were to look at this on a histogram, here's what this would look like. Say here's your data, and here's the mean. Here's the ones that have more data farther away. Anyway, more data on the outside, more data farther away. That is a much bigger standard deviation than something like this. See? Look here. I have very little on the outsides that are farther away. Okay? Few that are far away, a lot that are far away. Okay. All right. Last one, Simpson's paradox. Okay, so they give us table 1, which is the totals. So you find the percentages, and you got the totals. So actually, Fevela, or however you say his name, is actually a teensy bit higher. I mean, they're basically the same. You know, it's probably a fractional deal that's making it a teensy bit different. And then, so So they're about the same, or you could say Fevilla is a little better. But then when I take them individually throughout 2005, 2006, 2007, if I look at the years separately, then actually Lloyd ended up being higher on two of them, and Fevilla was clearly higher on one of them. So there was very much difference on that. So combined, it looks like Fevilla, or they're about the same. However, separately, it's more for Lloyd than Fevilla. So what we got going on is, let's see, Simpson's paradox. Okay, so down at the bottom. And then, oh, the conclusion you make with the separate groups is different when combined. Okay, the conclusion you make from these separate groups is different when combined. Question, how did I get this 81 right here?
How'd you get 90?
Oh, I don't know. Is this 59 out of 78? Is that like not 91? Is this 71 or?
It's like 75.
Oh, okay. That's cool. So that's like, so then, that's good. That's a stamp right there. Yeah, because that then makes my thing where every single time Lloyd was ahead. Okay, good. Combined, it's Fevilla, but however, separately, it's more Lloyd. Okay, good job. All right. Okay, you got me on track though. Where did this 81 come from? Yes, because this was made and lost, so it's a total of 81 for that set. So it's 62 out of 81. Okay. Boom, that's it. Yes, ma'am. Did I miss another?
Well, no, I averaged my new percentages. I mean, that's what they are.
Yes. Yes, you can. So then, yeah, I like that. Kristen averaged the new percentages. And so what did you get for the average of Lloyd when you averaged their percentages?
77.5, and the other one was 75.9.
Yeah, so it is. So when done correctly, Lloyd's higher. Okay, very good. All right, so that's it. Questions about that?